Hello everyone and welcome back to our channel Quaint Cosmos. Today we are diving deep into one of the biggest problems in modern physics. The problem is the clash between quantum mechanics and gravity. Gravity, that means general theory of relativity of Einstein. So the topic of discussion in today's video is the clash between quantum mechanics and general theory of relativity. You know that these two subjects, quantum mechanics and general theory of relativity, these two are main pillars of modern physics. Still, they are fundamentally incompatible because approaches are different. So, you know that general theory of relativity deals with massive masses. Means according to that theory, space-time itself works in the presence of massive masses, and the outcomes of this theory is deterministic in nature. And you know that quantum mechanics, this governs the smallest particles in the universe, from electrons to quarks. All are governed by the principle of quantum mechanics, and the results are probabilistic in nature. Means outcomes of quantum mechanics are probabilistic in nature. That is known to you. So you can see that approaches are different, outcomes are different. In case of general theory of relativity, it is deterministic, and in case of quantum mechanics, it is probabilistic. So outcomes are different. Again, so what is the reason between the behind the clash? What is the reason actually? Okay, so you know, according to general theory of relativity, space-time itself is not fixed. In the presence of massive masses, space-time bends, again it stretches. Okay, so this is according to general theory of relativity, but quantum mechanics assumes flat space-time. In the realm of flat space-time, the principles or the calculations or the mathematical equations are based on this assumption. Mathematical equations means I am talking about the governing equations which are used in the field of quantum mechanics. In that case, the approaches are based on fixed space-time or flat space-time. But according to general theory of relativity, you can see that space-time itself is not fixed. So there are differences between these two approaches. So this is one of the reasons behind the clash. Okay, again you know that if you talk about information paradox, then you know that according to quantum mechanics, information cannot be lost. Information is always preserved. So that is according to quantum mechanics. But if you deal with the problems like black holes or the Big Bang, then in that case, you know that information is not preserved. Information is lost permanently. So this goes against the principle of quantum mechanics. So these are the reasons behind the clash between quantum mechanics and the general theory of relativity. So to bridge the gap between these two theories, okay, to bridge the gap between these two theories, several theories have been proposed by scientists. Like string theory is there. According to string theory, particles are vibrating strings, and gravity is just another vibration mode. So according to string theory, this is the proportion. Means particles are represented by vibrating strings. Again, loop quantum gravity is there. That is another theory. What is that theory? According to that theory, when that theory actually quantum loop quantum gravity that that actually quantizes the space itself into discrete units. Yes, that theory quantizes space itself into discrete units. Again, holographic principle is there, and according to that, our 3D universe is nothing but the projection of a lower dimensional reality. So that is holographic principle. Again, experiments are going on worldwide. Means those are known as tabletop experiments, and scientists are trying to find the gravity in the field of the effect of gravity in the field of quantum mechanics. According to quantum mechanics deals with the fundamental forces. So forces come from particle exchanges in case of quantum mechanics. But in the realm of quantum mechanics, scientists have not still found any particle which is responsible for gravity. One name is given for that particle, which is known as graviton. You might have heard this name, graviton. Means gravity carrying particle, graviton. Okay, but experimentally, means practically, scientists still have not found that particle. But other forces like electromagnetism is one force, strong force is there, weak nuclear force is there, and they happen due to exchange of particles. Means their existence of all those three fundamental forces can be explained in the realm of quantum mechanics by using the concept of exchange of particles. But gravity, still they have not been able to include this effect gravity in their calculation. So these are the problems, and I have already mentioned few proposals by the scientists. String theory, holographic principle, loop quantum gravity, then experiments are there, practical experiments are being conducted worldwide by the scientists to detect the effect of gravity in the realm of quantum mechanics. So you can see that these two theories are no doubt the pillars of physics, both quantum gravity and they work flawlessly in their own domains. But when we try to combine them, then there is a problem. Then there is a clash. Okay. In their own domains, they work flawlessly, both the quantum mechanics and general theory of relativity. But the problem arises when we try to combine them. And I have already mentioned the need of combining them. Such as in case of black holes, there is a need to combine both the theories. And we have seen that both the theories break down when we try to combine them to solve problems related to black holes or Big Bang theory, or other theories are also there, other problems are also there. Okay. Anyway, so this was all about today's topic. That means if we solving this problem, what we will achieve by solving this problem? We would be able to know the reality of space, the reality of time, and the reality of universe itself. That we can expect if we could become able to solve this problem. That means if we could be able to bridge the gap between these two subjects, then we would be able to know the reality of space itself, to know the reality of time itself, and to know the reality of universe itself. Anyway, so this was all about today's topic, and this is the end of this video. Thank you for watching this video.